Lesson 3. The inverse normal distribution function. If x follows the normal distribution with a mean mu and a variance of sigma squared or a standard deviation of sigma, and for a given probability p, you can find the value of a such that the probability that x is less than a is equal to p on your calculator using the inverse normal distribution function. Let's do some examples. X follows the normal distribution with a mean of 20 and a standard deviation of 3. Find to 2dp the values of a such that the probability that x is less than a is equal to 0.75 and the probability that x is greater than a is equal to 0.4. We want to find the value of a such that the probability that x is less than a is equal to 0.75. On our calculator, we're going to go to distribution, then to the inverse normal function. Now we know the area up till this point is 0.75 and the mean is 20 and the standard deviation is 3. This gives us a value of a as 22.02 to 2dp. For part B, we want the probability that x is greater than a is equal to 0.4, but the inverse normal distribution function on the calculator only works for the probability that x is less than a is equal to p. And so if everything after a is 0.4, that means that everything before a will be 0.6. And so on our calculator, for the area, instead of 0.4, we'll use 0.6 with a mean of 20 and standard deviation of 3. And this will give us 20.76 to 2dp. Let's do one more example. Plates in a factory have a diameter d centimeters, which can be modeled as d follows a normal distribution with a mean of 20 and a standard deviation of 1.5. Find the interquartile range for the diameters. Now we know that the probability that the diameter is less than the first quartile will be equal to 0.25, as 25% of the data lies before it. So we're going to let the area equal 0.25 with a mean of 20 but a standard deviation of 1.5. And this will give us that Q1 is equal to 18.99 to 2dp. Now we know that the probability that the diameter is less than the third quartile will be 0.75, as 75% of the data will lie before the third quartile. And so now we do 0.75 as the area, and we get that the third quartile will be 21.01. And therefore, the IQR, the interquartile range, will be equal to Q3 minus Q1, which is equal to 21.01 minus 18.99, which will give us 2.02 centimeters, which is also to 2 decimal place. And that's about it.